Hello, and welcome to the instructional video of the SunSaluter solar panel rotating tracker. SunSaluter is a non-profit organisation dedicated to improving energy and water access in the developing world. Our goal is to encourage solar energy access through economic empowerment. We have spent many years refining our technology for wider use and are now making it open source. Solar energy is a proven method for fighting energy poverty. However, it is still too expensive for many poor rural consumers. The problem with many solar panels is that they're fixed in a static position and don't rotate to follow the sun, therefore generating less electricity than they're capable of. Our technology, the SunSaluter, is the only solar tracker that is low cost and dependable enough for the developing world. It is 30 times less expensive than other solar trackers, consumes no energy, and boosts solar panel output by up to 30%. Using only gravity and water. This video runs through how you can get started building your own SunSaluter, including materials, steps along the way, and helpful tips. The SunSaluter design is intended to be adapted for different locations, using different materials. Check out sunsaluter.org for images and designs of other designs that have been developed all around the world. There is more than one way to build a SunSaluter. When considering materials for your SunSaluter, you'll need some sturdy lumber, bamboo, or metal. This material can be of any size or thickness as long as it can support the weight of the panel and weights. You're going to need 4 pieces greater than 4 feet and another 4 pieces greater than 3 feet, which we'll assemble shortly. You'll need to find brackets that combine these together and support the panel at the same time. The most important component is the solar panel itself. These panels range in size. In this video, we're using a 47 by 21 inch 100 watt panel. You can make a choice based on your space and budget. You'll need a water bag and counterweight, combined with a water purifying system with a valve for regulation. With simple tools, you'll be able to build your SunSaluter with a saw, hammer, zip ties, wire, measuring tape, and nails. You'll find a full detailed list of materials linked below or on the website. The first step is to measure and cut the frame using a tape measure or length of string. To build the frame, you can use any thickness of timber, bamboo, or metal as long as it's strong enough. Here we're using 3 by 1 inch pieces of timber. You could use anything up to 4 by 2 inches for extra strength and sturdiness. When preparing your main supports of the A-frame, you'll need to cut the timber into 4-foot lengths. You'll see that we already have our timber in shorter lengths for the sake of this tutorial. Now when it comes to frame assembly, take the 2 pieces of 4-foot lengths you just prepared. These 4 pieces should be of equal length. At one end of each piece, cut off a small section at a 45-degree angle. These angled ends will become the feet of the A-frame, so it will sit flat on the ground. Find a flat location where you'll be able to set up your SunSaluter. We are using a 45-degree T-shaped bracket we found at our local hardware store. Now you can use just about any size bracket you can find, as long as it's able to put these 2 lengths of material at a 45-degree angle at the top to form the A. This will help act as the main support center for the solar panel itself. We're now going to take the remaining pieces of timber to create the supporting bracket on the frame for sturdiness. Using one of the 3-foot lengths, attached using galvanized nails or twine, this supporting piece will help stabilize the A-frame, which you'll see shortly. Moving on to finding the solar panel's balancing point and fixing brackets. This part can be tricky. We'll need to find the center of the solar panel on its longest edge. This will act as the pivot point so it can move consistently throughout the day. You'll need to measure your solar panel and find exactly halfway down both sides, making holes on either side. Here, we are bending a flat piece of aluminium we found in the hardware store to create our bracket. We have taken a simple piece of metal and bending it on a 45-degree angle to create our support bracket. Using a bolt between this bracket and the A-frame to act as the pivot point for the SunSaluter to be able to track the sun. If available, you can also buy an existing L bracket that might be stronger. You'll need to apply a supporting bracket to your solar panel and have the attach before the next step. With your brackets already attached to your solar panel, take a measurement of the outside edges of each bracket to gauge the width. Using this measurement, you'll be able to determine the distance between the 2 A-frames while standing to support the solar panel. With this measurement, we can now cut our remaining lengths of timber for crossbars and support. Fix them approximately halfway down the A-frame with nails or twine, as you can see here. Apply to both ends. While in the center of your A-frame supports, you'll need to attach another piece of further support that can hold your batteries and capture the panel's energy. With these last pieces of timber now applied, we have a sturdy A-frame and are ready to attach our solar panel. Mounting the solar panel can be difficult with one person, and you may need an extra set of hands. No weights need to be applied just yet. The solar panel should sit in the center, supported by a bolt between the A-frame and brackets mounted to the panel. The pivot point needs to be above the panel for the solar panel to swing correctly. The solar panel should just sit balanced while at rest. Now we are almost there. In the final stages, we need to look at the shorter ends of our solar panel and find exactly halfway. Like we did with the longer ends, here we need to make another hole at each end, ready for a zip tie support for our water purifying bag and counterweights. Our water bag is a pre-purchased camping water bag. This comes with tube and water purifier at the end. These elements can be found and bought separately, or in some cases, it is easy just to use a piece of tube, water purifier, and old soft drink bottles. Our water bag is supported by a simple hook that we fastened out of a clothes hanger, looped into a zip tie attached through holes of the solar panel's shorter ends. It's important to have a hook as this allows you to remove the water bag and counterweights easily. With our bag, we have attached the water purifier to the bag, filled with water and mounted to the panel. Now this is where it gets tricky, understanding how much water we need in the bag and how much for a counterweight. We filled the water bag with 4 litres of water, which equates to 4 kilograms. After filling, we lightly press down on the bag to release any excess air, rolling the top down over itself twice, ready for hanging. A counterweight should weigh slightly less than your water bag for it to be able to correctly rotate throughout the day. Using the zip ties and hooks, hang both bags at opposing ends. At this stage, the water bag should be hanging lower than the counterweight. Using the valve to adjust the flow rate, which controls the solar panel's rate of rotation, open or close the valve to increase or decrease the rate of flow. This may take several days to reach your optimal flow rate to track the sun. To ensure the flow rate is correct, measure how much the water drips out in a 15-minute period. The ideal flow rate should rotate the whole system in 10 hours, so you should have 100 to 200 milliliters of water coming out every 15 minutes. For larger or smaller volumes of water, you may have a different flow rate. We encourage you to try various methods. And remember to face the side with the water bag to the east, so that it faces the sunrise every morning. For a full table to help you with your calculations and detailed step-by-step written instructions, please visit our website at SunSaluter.org. The SunSaluter has been deployed in numerous countries around the world, in various settings ranging from small villages to orphanage rooftops to high wind areas and coastal regions. We encourage you to adapt your SunSaluter design to the physical and social needs of your geographical location. As an open source hardware initiative, what we have shared here is simply one suggestion for how you might build your own system. We would love to hear from you if you have found an improvement to the SunSaluter design for your region. Please connect with us on our website.